Okay, this is the pre-lecture on population viability analysis, and I'm just going to spend probably about 10, 12 minutes talking about the context of PVAs with respect to the research community and also then with respect to the ESA and the management of endangered species. And so this is kind of a good news, bad news thing that I think is a theme that um, it actually pertains to a lot of topics in conservation, and so I'll mention that as we go through. So these, of course, one's a grizzly bear and the other one's a Furbish's lousewort. They both look like perfectly viable individuals here, but they're two species that were um, addressed early on with respect to viability assessment. So Eric Menges did population viability analysis on an endangered plant, the Furbish's lousewort, published in 1990. Mark Boyce was famous for doing PVAs on grizzly bears. He did an annual review in 1992. We're hitting into the heyday of the literature on population viability analysis in conservation. And so this next slide, what I did was I went onto the ISI Web of Science and did a search. And so I said, well, what is the magnitude of the literature on PVA and conservation relative to the conservation literature? So I measured the conservation literature by searching terms biological or ecological and then conservation. Just could have done it a number of different ways, but that was what I used. And then for PVA, I assessed it by searching on the terms population viability analysis or PVA and conservation. So if you just do PVA, you get a lot of stuff that has nothing to do with population viability analysis. So the latter literature has grown from 4 papers in 1990 to a peak of 71 in 2013. The conservation literature grew from 165 in 1991 to 3,500 almost in 2015. And if you just divide the PVA over the total literature, this is what the graph you get. And so there's a couple of things that you should note on this graph. One is that PVAs, since they've become in fashion, have been ranged anywhere from about 2% to 7 or 8% of the literature. They were going in great style up through the mid-1990s. They kind of crashed at the end of the 1990s, and I'll talk for a moment about that. And then had a resurgence in the early 2000s. But for many years now, the number of papers hasn't changed very much, and the literature is growing in size, and so we see it seems to settle in at some kind of steady state around 2% of the literature. Now, of course, this is just the peer-reviewed literature, and if a zoo or an agency does a PVA, there's no guarantee that that makes it into the peer-reviewed literature, and so it's just reflecting some kind of academic interest in PVAs and sort of a I think what the point that's common here is that we gain a lot of enthusiasm for technological tools that come on for analysis and conservation. We tend to overestimate their ultimate utility, and so there's a tremendous interest in a lot of publication on those sorts of things, and then it settles down into some lesser state where we have a more sober realization of the kinds of problems that kind of tool helps to resolve. And I think that's just worth noting, because we wonder what are those sorts of flash in the pans today, where everyone is over exuberant about the potential for, I don't know, decision analysis or occupancy models or genetic tools or whatever to solve problems that we may in 10 years from now feel like that they have a more constrained role in our science. Okay, so what happened to the demise, to cause the demise of the hopeful era of PVAs? I'm not going to go into how PVAs are done or that here, because that's really stepping on Mickey's toes for tomorrow, but suffice it to say that there was a lot of enthusiasm about PVAs in the 90s, a lot of expansion of different ways that you can do PVAs. There's continued to be expansion of the ways that you can do PVAs. In 99, Don Ludwig said that model choices result in a lot of variability among models, and it's not often clear why one choice is better than any other, and that this means that you can't be very highly certain about your outcomes. Same year, Paulette Birger-Dudek, who's at Lewis and Clark, revisited data and tried to backcast what would have happened to a plant species that she had many, many years of demographic data on, and found that the PVA that would have been constructed 10 years earlier would have done a very bad job of predicting what the outcome was after 13 years. Then in the early 2000s, Feiborg and Elner wrote a series of papers looking at the robustness of PVAs, and suggested that PVAs are good for prediction out about 10 to 20% the length of the data used for construction. So for every 5 years of data, you can predict out one year. That's not a very hopeful look at PVAs. And Miller and Doak did some assembling of data, and they suggested that even the best of studies have either multiple populations and not very long time spans, or few populations and many years of data, but hardly any have many year populations and many years of data, the kind of thing that you might really want to have robust prediction. And so the next couple slides are just some screenshots of ISI Web of Science that reports on some of that critical literature. So if you search on Elner and population viability, and then sort by most highly cited, here are the things that come up. These 4 papers, 2001, 2000, 2002, 2003. So this is all sort of on this issue of, well, how much can you really get out of a PVA in terms of prediction, and that this is not, is a broader literature than just those 2 guys. And so my cutesy thing of the day is the PVAs get Y2K'd, and that around the year 2000 people started jumping on it about how uncertain we may be at the end of the day in terms of predictions. And in here is Paul Birger-Dudek's paper, Don Ludwig's paper, Steve Beisinger and Westfall's paper on demographic models, etc. That doesn't mean that they've gone away, and I think it just means that we've had to be more clever and more thoughtful about what we do with them. Elizabeth Krohn started a working group. I think it was an NC's working group, but a number of people were in that group, and a lot of clever people in that group, and they were working on PVAs, and particularly with respect to plants, but then how they might be useful. And one of their papers, they did something that Paulette Birger-Dudek did, and she was actually an author on this. They went and looked at lots of species. They evaluated how well data on 82 populations of 20 species did in predicting plant dynamics, and they said that 40% of the observed populations fell within the forecast 95% confidence limits. And so, this means that most of our predictions are falling outside the confidence limits of PVAs, and we'll talk a bit about this on Thursday. But that's that provides a big challenge for the use of PVAs in making meaningful predictions, but it's not an unsurmountable one. Perhaps more interestingly, and I think that I would recommend that you pause my blabbering right now and take a good hard look at these tables from a 2011 paper by Krohn, where they're looking at, they're doing a survey of people, and they say, as applied in general, how often do you think the matrix models would accurately predict or be useful for estimating population growth, future population size, population structure, etc. And then towards the left we have high probabilities, towards the right we have low probabilities. And people seem to suggest that it's good for coarse things like distinguishing whether populations are growing or declining, and to predict the relative benefits of particular management options. And I think we can come back to that seems to be a very robust use of these models, that people are most bullish on that. If you have 2 different options of how you might be able to manage things, does one appear to be better in terms of likely viability? And then over on the right, there's places where you have 3 different types of or goals for PVAs: to look at the relative effects of management, to predict extinction risk, or to look at population growth rate. And those represent these 3 colored bars. And the question is, in cases where matrix models fail to predict something, the relative effects of management, for example, how important is, and then there's and again, often, sometimes, never, so more important to the left, less important to the right. A lot of things fall right down the middle, so it's a little bit less clear there. But you see that I think the normative answer is sometimes in all of these things. But they're interesting questions to look at, so I encourage you to stop and read them. So Then we can think about this with respect to the ESA, and so there are a number of papers that talk about PVAs in practice. Shea Wolf, for example, and a group wrote a paper last year, Beyond PVA: Why Recovery under the Endangered Species Act is More Than Population Viability, and they make the points that population viability is not an explicit delisting criteria. Delisting requires documenting that you back out those 5 listing criteria: threat, habitat loss, overutilization, disease and predation, other man-made factors, or the inadequacy of existing regulatory mechanisms. And that meeting some threshold of population viability is also not the goal of the ESA. The ESA envisions functioning ecosystems with species that are at ecologically relevant population sizes over significant portions of their historic ranges. So the words in the ESA are: the recovery species is one that's not currently in danger of extinction throughout all or a significant portion of its range, and not likely to become so in the foreseeable future. And so it's not clear that you need to have a PVA to support a recovery of an endangered species, but it seems like it might be handy. So nevertheless, the PVAs has been critically tied to a call for objective recovery criteria. And this is from the Wolf paper. They say that over the past 20 years, numerous reviews have identified shortcomings in recovery criteria, showing that they often lack clear biological rationale, and that they're not sufficiently objective and measurable, and that the recovery criteria are often set below levels necessary for long-term persistence and ecological viability. Well, these are all problems that could be addressed, at least if not solved, by PVAs, and so you get frequent calls for PVAs in recovery planning. And so Miley Neal and Mike Scott got a grant from the Department of Defense to look at recovery planning, and Miley Neal has gotten on the ball and published a lot of this stuff. Mike Scott's been much slower about it, and so Miley Neal is taking the plants and Mike Scott the animals. So there's no parallel thing that we can look at with respect to animals, but that would be interesting. But this is these guys' take on plants, where they looked at 642 plant species plans, and they asked when we would want to have a PVA. And so the number of species species recovery plans where you'd use a PVA, and then this goes from left to right here: conducted prior to the plan writing, conducted in the plan, used to set recovery criteria, will be used to evaluate recovery criteria. Recovery criteria written as probability of recovery and recommended in recovery strategy. So here you have a peak of about 120 species, or less than 20% of these taxa having a listed species, suggesting that a PVA is recommended in the recovery strategy. Most of the time, there's actually relatively small call for PVAs in these plant recovery plans, and I think that's because PVAs, in order to do one that has that robustness that Elner and Feiberg call for, requires a lot of resources. Say I'm on slide 11 here, and I'm going to have to get to slide 16, and I'm at 13 minutes. So what I'm going to do is I'm going to stop this one now, and I'm going to pick up and make a part 2 of this.